Welcome to Nihal Academy. This is your physics mentor Pavan. So in the previous videos we discussed chapter wise, but we don't have that much time to discuss chapter wise. So I verified that previous 20 to 25 years papers. So from that, I selected the which model is repeating. So those high weightage questions now we'll discuss. So these high weightage questions I will provide by 2 or 3 parts. So don't skip these parts which I will provide 2 or 3. So these are very important models. These models are continuously repeating in the every year NEET. Now we'll see the first question. If the magnitude of sum of two vectors is equal to the magnitude of difference of the two vectors, the angle between these two vectors is. So the two vectors will take it as a vector A and vector B. Now magnitude of sum of two vectors, sum vector A plus vector B. So magnitude means that we have to take, and it is equal to the magnitude of difference of the two vector, that is vector A minus vector B. So now the magnitude, so now it is equal, so we have to find the angle between these two vectors is. So now squaring on both sides, so that means vector A plus vector B whole square. So that vector A minus vector B whole square. As per vector identity, we'll use the vector identity. So we can write it as vector A square plus vector B square plus 2AB cos theta is equal to, and this we can write it as vector A square plus vector B square minus 2AB cos theta. Now we can cancel vector A square and vector B square, we can cancel, and we will bring this minus 2b to the left side, then it is equal to 2AB cos theta, that is plus 2AB cos theta is equal to 0. 2AB cos theta plus 2AB cos, so it is equal to 4AB cos theta is equal to 0. So now we have to find the angle. So this is anyway 4AB is not equal to 0. So then we have to equate to cos theta is equal to 0. So then cos theta is equal to 0. So from this we can write it as theta is equal to, we'll take to the other side, then it will become cos inverse 0. So cos which value is 0? It is, so cos 90 degrees it is equal to sin 0. Sin 0 value 0. So this value it is equal to, so cos inverse cos 90 degrees. Cos inverse and cos cancel, then theta is equal to 90 degrees. Now we'll go to second question. The projectile is fired at an angle 45 degrees the horizontal. Elevation angle of the projectile at its highest point as seen from the point of projection is. So that means a body is projectile. So this is the projectile motion. So for example, so at this point, so the direction of velocity, so we have to draw the tangent to this point. So this is the velocity direction, that is u, and it is projected with the 45 degrees angle. So the angle is given here, it is 45 degrees. Elevation angle of the projectile at its highest point as seen from the point of projection. So this is the point of projection and this is the highest point. So angle of elevation, so that means this projectile makes an angle with the highest point. So now we have to calculate this angle. So this angle will take it as a alpha, let it be alpha. So we have to calculate this alpha. So now how to calculate alpha? So as per the trigonometric functions, so this total path it is traveled, it is equal to the range. We'll call it as a range R. But we have to take the distance from point of projection to the maximum highest point. The highest point, maximum height. So highest point, so that is h. So from point of projection to this h, it is equal to half of the range. So this is equal to r by 2. So we know that h r by 2, then we can write the relation tan alpha is equal to h by r by 2. So what is h? Maximum height. So we know the formula u square sine square theta by 2g. So how can you calculate the range? So u square sine 2 theta by g. So we'll use these formulas to calculate h and r. So what we have to calculate? Alpha. So tan alpha is equal to h by opposite side by adjacent side, h by r by 2. Here we have to calculate h and r. H is the maximum height. So this maximum height, it is equal to u square sine square theta by 2g. So from this we can write u square theta is equal to 45 degrees. Theta is equal to 45 degrees. Sine square theta means 45 degrees by 2g. So from this we can write u square sine 45 1 by root 2. So 1 by root 2 whole square by 2g. So from this we can write u square 1 by root 2 whole square means root and square cancels, so that is 1 by 2. So 1 by 2 by 2g, so that is equal to 4g. So this is equal to u square by 4g. So what it is? H maximum. Now we will calculate that range R is equal to u square sine 2 theta by g. U square sine theta is equal to 45. 2 theta, 2 into 45, 90. So sine 90 degrees by g. This is equal to u square sine 91. So u square into 1, otherwise you will write u square into 1 by g. So this is equal to u square by g. So r value, so we calculate the range, that is u square by g, and the h maximum u square by 4g. So r is equal to u square by g, and this is h maximum. Now we will substitute these values in the tan alpha is equal to h by r by 2. So take tan alpha is equal to h by r by 2. So this is equal to h u square by 4g by r by 2. So this is r value. R by 2 means u square by 2g. So it will become u square by 2g. This is u square by 4g and divided by u square by 2g. If you simplify u square cancel, g cancel. Now tan alpha is equal to here 1 by 4 by this is 1 by 2. We will write it as 1 by 4 into 2 by 1. So 2 here, 2 times cancel, 1 by 2. So tan alpha is equal to 1 by 2. Alpha is equal to 1 by 2. So from this we can write alpha is equal to, take the other side, then it is equal to tan inverse. So tan inverse 1 by 2. So this is the alpha value. So alpha is equal to tan inverse 1 by 2. So what is the alpha? Alpha is the elevation angle of the projectile at its highest point as seen from the point of projection. That means point of projection to the highest point, that is alpha. It is equal to tan inverse 1 by 2. See the next question. A stone tied to the end of a string of 1 meter long is whirled in a horizontal circle with a constant speed. If the stone makes 22 revolutions in 44 seconds, what is the magnitude and direction of the acceleration of the stone? So we have to calculate that acceleration of stone. So acceleration of stone AC we have to calculate. So we know the formula AC, it is equal to omega square R. So is equal to number of revolutions by time. Then we will get the new. Given radius R, it is equal to 1 meter. And number of revolutions are given, so we can calculate the new. It is equal to number of revolutions 22 by time is equal to 44. So from this, we will get that it is equal to 1 by 2. So this is 1 by 2 hertz new frequency. Calculate W. So W is equal to 2 pi nu. So 2 pi is equal to 22 by 7 into nu value 1 by 2. So 2 cancel. So this is equal to 22 by 7. Is the W is equal to radian per second. Radian per second. Now acceleration AC is equal to omega square R. So omega square means 22 by 7. 22 by 7 whole square into R value, it is equal to 1 meter. So 1. So this is equal to 22 into 22 by 7 into 7. We know that 22 by 7 value, it is equal to 3.14. So 3.14 into 3.14. So this is equal to 3.14 into 3.14. 4 4 16, 1, 4 plus 1 5, 12, 4 1 3, 12, 4 9. So this is equal to 6 9 5 8. So 9. So this is equal to 9 8 9 8 5 9 6. Decimal after 2 plus 2 4 digits, 1 2 3 4 digits. So 9.8. So this is meter per second square. So 9.8596 meter per second square. Three blocks A, B and C of masses 4 kilogram, 2 kilogram and 1 kilogram. So this is 4 kg and this is 2 kg and this is 1 kilogram masses. They respectively are in contact or a frictionless surface as shown. Yes, A, B, C are in contact. If the force of 14 newtons is applied, so the force here, this is the force, net force acting on the three blocks, that is 14 newtons on 4 kilograms block. Then the contact force between A and B. So we have to calculate the contact force between A and B. So how can you write the contact force between A and B? FAB, it is equal to, we know that F is equal to MA formula. So from that, mass it is equal to, so force is acting on the 4 blocks. So we have to leave it this for block A and take the sum of the B and C masses. Sum of the mass of B and C. So that is equal to MB plus MC. This is the mass and acceleration. So here we have to calculate the acceleration. So acceleration A is equal to F by M. So what is this F? F is total force, that is net force, F net by mass is total mass, that is capital M. So net force is equal to 14 newtons by mass, that is equal to M1 plus M2 plus M3. So it is equal to 14 by M1 is 4 plus M2 2 plus 1. So this is equal to 14 by, so 4 plus 2 6, 6 plus 1 7. So 14 by 7, it is equal to 2 times cancel, then it is equal to, so therefore the acceleration it is equal to meter per second square. So we calculate the acceleration. Now I have to calculate the force acting between A and B, F, block B and block C. So MB plus MC into A. Here very easy. So if the force is acting on the block A, then we have to leave the block A and add these two. That's all. So MB, that is 2 mc. So mass of the seat is equal to 1 into acceleration we got 2 meter per second square. So into 2. So this is equal to 2 plus 1 3. 3 into 2. So 3 into 2 it is equal to 6. What is this? So force acting between A and B. This is contact force between A and B. It is equal to 6 newtons. Now also the fifth question. A 0.5 kilogram ball moving with speed of 12 meter per second strikes a hard wall at an angle of 30 degrees with the wall. It is reflected with the same speed and at the same angle. If the ball is in contact with the wall for 0.25 seconds, the average force acting on the wall is. Now the ball hitting the wall with 30 degrees angle and reflected back to 30 degrees angle. Now here we have to find out the resultant vector, it is in the direction of normal. Now this velocity v we have to, that is for example this is v1 and here the velocity is v2, and this velocity we have to divide the components because it makes an angle, and then in this direction, that means with the wall, so it is towards wall, so we have to take the towards wall. The direction is, this is v1 cos theta horizontal component, this is, and this vertical component, so this is also towards wall, so we have to take it v1 sin theta. And now second one, here this velocity is making an angle with 30 degrees when reflected back from the wall. So then here this V2 is divided to components. So that is coming out. So we have to take the direction like this. Here this is V2 cos theta. So these two are same and in the opposite direction. So cancel. Now here in the vertical direction. So it is outside. So that is V2 sin theta. V2 sin theta. Now the resultant velocities are in the normal direction. So now we have to find out the average force acting on the wall. So how to calculate the force? It is equal to rate of change in momentum. So delta P by delta T. So delta T is given, that is 0.25 seconds. So here delta T it is equal to 0.25 seconds. But we have to calculate change in momentum. So that is delta P is equal to, so momentum, so this is final momentum minus initial momentum. So the final moment is equal to 12 meter per second and the same mass. So m is equal to 0.5 kg. So this is the information given. So we know that V1 is equal to V2 and mass is 0.5 kilogram. So momentum, mass into velocity. So P is equal to mv. This is the final. So final velocity. So that is reflected. So minus, we have to take minus m, and the final velocity is the resultant, that is v2 sin theta. V2 sin theta minus initial momentum. So that is equal to resultant v1 sin theta. So mass is m and v1 sin theta. Here same mass and velocities are same. v1 v2 we can replace with the v. So that is, here this is, will take it as a v. So v1 v2 plus we can replace. So we can replace v2 v1 with v sin theta minus m v sin theta. Now if you look at the board, minus mv sin theta minus mv sin theta. So this is equal to minus 2 mv sin theta. From this we can write delta p is equal to minus 2 into mass m, that is equal to 0.5 into v. v1 is equal to v2 is equal to v, that is equal to 12 meter per second. So 12 into sin theta. So theta value 30 degrees. So sin 30 degrees. So this is equal to minus 2. So minus 2 into 0.5, 1. 2 5 10. So decimal after 1 is, so it is equal to 1. into 12 into sine 30, 1 by 2. So 2, 6 times. This is equal to minus 1 into 6, minus 6. This is delta P. So kilogram meter per second. Now we have to take that magnitude of this delta P. So that is equal to det delta P, it is equal to det minus 6. So it is equal to 6 kilogram meter per second. Now force, average force which is acting on the wall, F is equal to delta P by delta T. So this is magnitude of delta P. So that is 6 by delta T, 0.25. 0.25. This is equal to 0.25. We can write as 25 by 100. So 100 goes to numerator. So 6 into 100 by 25. So 25 4 times cancel. Now it is equal to 6 force 24. So this is force F is equal to 24 newtons. So therefore the force acting on the wall, so that is in the time interval 0.25 seconds, the average force acting on the wall is equal to 24 newtons. And the direction towards wall, this force, this is towards wall. Now see the sixth question. Consider a drop of rainwater having mass 1 gram falling from a height of 1 kilometer. It hits the ground with a speed of 50 meter per second. Take G value 10 meter per second. Find the work done by the gravitational force and resistive force of air. So here, dropping from the height. So what is given here? First we'll find out that a drop of rainwater having mass is given, m is equal to 1 gram. So this is meter per second, so we'll convert into the kilograms. So that is equal to 10 power minus 3 kilogram. And next, height, that is equal to the 1 kilometer. So h is equal to 1 kilometer. So we have to convert into meters, that is equal to 10 power 3 meter. And G value is given, it is equal to 10 meter per second square. Now the first question is asking to calculate the work done. So W, work done by the gravitational force, Wg. So work done by the gravitational force is equal to with the virtue of height. So that is equal to, it is stored as a potential energy in the body. So it is equal to mgh. So mass is 10 power minus 3, g value 10, height it is equal to 10 power 3. So 10 power 3, 10 power 3 we can cancel, then it is equal to 10. Work, joules. So this is equal to work done by the gravitational force. Now second one, resistive force of air, work done by the air. To calculate work done by the air, so the total work done in this case, that is work done, net work done, it is equal to the work done by the G plus work done by air. So already we calculated work done by the G, so I have to calculate the net work done. Here the net work done, it is in this case from the work energy theorem, the net work done, it is equal to change in kinetic energy. So change in kinetic energy means half mv final velocity square minus half mv square, this is initial velocity. We have to simplify this value. So half mass is 10 power minus 3, 10 power minus 3 into final velocity, that is equal to before hitting the ground 50 meter per second. So 50 square, 50 whole square minus half, mass is 10 power minus 3, and initial velocity. The initial velocity, the body is dropping from a certain height. Here the initial velocity, so velocity initial it is equal to 0. So I have to substitute 0 square. So that means it is equal to 0. So this term will become 0. then half into 10 power minus 3 into 50 square, we can write as 50 into 50. Now 2 here, 25 times cancel. Now this is equal to 525s. It is equal to 125. And here 0. So 1250 into 10 power minus 3. So this is equal to 1.25. What is this? Work joule. So this is equal to 1.25 joule. So we know that total work done, that is equal to 1.25 joules, and work done by the gravitational force is equal to 10 joules. So we can calculate the work done by the air, that is air resistance. So that total work done, it is equal to work done by the gravitational force plus work done by the air. So now this is equal to 1.25 is equal to, this is 10 plus WA. So we have to calculate WA. So WA, work done by the air, that is resistive force of air, it is equal to, this 10 is plus, so if you bring to the left side, minus, so 1.25 minus 10, so this is equal to minus, so 10.00, and this is 1.25 minus, so subtract, so this is we have to borrow, so 10, so 10 minus 5, 5, and here 9, 9 minus 2, 7, and this is 9, 9 minus 1, 8, so 8.75. So this is equal to minus 8.75 joules. So what is this minus? Indicates that resistive force, opposing force. So that's why that is negative minus. So WA, it is equal to minus 8.75 joules. A particle of mass m1 is moving with a velocity v1 and another particle of mass m2 is moving with a velocity v2. Both of them have the same momentum, but their different kinetic energies are E1 and E2 respectively. If m1 is greater than m2, then, so what about the energies? Is asking about that kinetic energies. So we have to calculate kinetic energies. So now here what is given here? Both of them have the same momentum. So that means P1 is equal to P2. And next, their kinetic energies E1, E2. So we know the relation between the kinetic energy and momentum. So that is, so Ke is equal to P square by 2m. So first we will apply to the first particle. So that is the Ke, it is equal to E1 for the first particle. So E1 is equal to P1 square by 2m1. And we will apply to second particle E2. It is equal to, so P square by 2, P2 square by 2m2. We know that P1 is equal to P2, we will take it as a P. Then this is 1, so we will take it as a 2, so 1 by 2. That means E1 by E2. So E1 by E2, it is equal to, what is the first one? P1 square, P1 square by 2m1 divided by, so P2 square 2m2, we will write it as a into. That means the reciprocal of this fraction, that is 2m2 by P2 square. So this is equal to, P1 is equal to P2 is equal to P. So you can substitute P square by 2m1 into 2m2 by P square. P square cancel, 2 cancel. Then here it is equal to m2 by m1. And in the problem it is given that m1 is greater than m2. So m1 is greater than m2. That means E1 by E2 is that here the condition is m1 greater than m2. m1 and E1 relation is reciprocal. So m1 is greater means, then what about E1? Less. So E1 is less than E2. So this is the relation. So kinetic energy is that is E1 is less than E2. That means kinetic energy of the first particle is less than the kinetic energy of second particle.